Okay guys, right, let's have a look at some of these A-level problems from the paper, the summer paper, June 2018. So we're dealing with small angle approximations in this question, and there's some stuff that we kind of need to know. You do need to know the approximations for your small angles. So I've kind of put them here, the ones that we're using. So these are to do with when theta is small angle approximations. That's the key thing. This only works when theta is very, very small. Alright, and I'll show you why in a minute. So the two things you need to be aware of, and you need to have these in your mind, is the cos theta one and the sine theta one for this question. Sine theta is approximately theta when theta is very small, and cos theta is approximately the same as 1 minus theta squared over 2 when theta is very small. What does that mean? I'm just going to quickly take you into Desmos for a second to show you exactly how this works. Alright, so bear with me for a minute. So here's the sine curve. So we talked about this, didn't we? Sine theta. So I put sine x. X is theta. A is 1, so we're just talking about sine x. There's the curve of sine. You should be very familiar with that. Now we talked about sine theta is equal to theta. So sine x is just equal to x. So I've put on the line y equals x. Right, let's add it in. There we go. And can you see when theta is very small? Let's zoom in. When theta is very small, those two curves, the sine curve, which is the red one, and the line y equals x, look at, they're pretty much exactly the same values when theta is small. They start to sort of diverge about here. Alright, so when theta is tiny, this is a pretty good approximation that sine x is just x. And the same is true for cos x, cos theta, and that approximation 1 minus x squared over 2, alright? But let's just, in our question, we didn't have sine x, we had sine 3x. If I change that a, the number in front of x, if I change that to a 3, can you see what's going to happen to the curve, the sine curve? This approximation no longer works. It's nothing like each other. So we have to find out what, y equals what is going to be approximately the same as sine of 3x. Well, if we put our value of b up slightly, we can start to get the curve back, and it works out that it's 3x. Okay? Kind of makes sense, alright? So sine 3x is approximately the same as 3x. So we'll put that into our question. Hopefully this is giving you a bit more of an understanding rather than just telling you what the approximations are. So for this question, we need to put in, we've got sine of 3 theta, not sine theta. And I just showed you that sine 3 theta is approximately, that should be approximately 3 theta. That worked out, didn't it? Okay, but what about cos 4 theta? What's cos 4 theta going to be equal to? So let's go in and have a look at that as well on Desmos quickly. I'll turn these two off. Let's get rid of the sine curve and the y equals x. Let's look at the cos curve. Alright, I'm going to zoom out a tiny bit here. Zoom out a little bit. We know that we've got cos 4x, so I'll put that c value up to 4. So this is what the curve looks like. It's all to do with graph transformations, these relationships. So this curve, see this one here, that's an approximation for the cos curve, sorry. But we've changed the cos curve. So we're going to change our value of x to match it. So we get 4x, and you can see if I put that d up to 4, okay, it's going to be approximately the same. But it's not, you're saying. No, you're right, because I've forgotten something, haven't I? This is a very important point. You need to put the 4x into brackets in the formula. So this d value, that needs to be in a bracket, and that's important as well for the question. Okay, so we're going to use this. We're going to use 1 minus 4x all squared over 2 as our approximation for this question here. Okay, so let's go back in. And it's going to be where's my pen gone? So 1 minus, and remember what I said, put it into a bracket, otherwise it doesn't work. 4 theta over 2. That is the approximation for cos 4 theta. So let's get on with the question. We've got to find an approximate value. Alright, so let's sub in these approximations. So we've got 1 minus, and we're changing cos 4 theta to 1 minus 4 theta all squared over 2 over 2 theta, that's alright, 2 theta, times sine 3 theta, sine 3 theta is just 3 theta. So now we're just going to play around with this algebra and simplify it, and then we'll get something that will give us a value, hopefully. And thetas will cancel out, that's what I'm really after here. So I'm just going to sort out the top of this. If I was to drop these brackets, I would get 1 minus 1, which is 0, and the minus times a minus 4 theta all squared over 2 would become plus. So I'm just, those ones are going to cancel out. If I expand this bracket with a minus times everything by minus 1, that one's going to cancel with this one here. Minus times a minus is a positive, so we're just going to be left with 4 theta all squared over 2, all over, and 2 theta times 3 theta is going to be 6 theta squared, okay? So I'll bring it down, so I'm running out of space already here. This is going to simplify to, this will be 16, I've got a bit of room here, let's just do one more. 16, don't forget to square the 4, theta squared, over 6 theta squared, okay? That's over 2 as well. So we've got 16 over 2, which is 8 theta squared over 6 theta squared. Theta squared cancel out, and you end up with an answer of 8 over 6, which can be simplified to 4 over 3. Alright, I hope that's been helpful.